Hey, now we're going to look at how can we add and subtract fractions. In order to add and subtract fractions, they must have a common denominator. If they don't have a common denominator, then you can't add them or subtract them. So that's where I'm going to begin. I'm going to begin by trying to find this common denominator. And with two fractions, there's kind of a trick to, just maybe like a shortcut way to do it, and you'll see here as I get to it. The denominator here is 3x minus 2, the denominator here is x minus 5. So these two fractions they would be common if they looked like this. In other words, if I put one of these over here and I put one of these over here, in other words, make it so that each fraction has both of those denominators, well then it's common, right? They look alike, so they're certainly common. Well, I can't just put this one here and put this one here and call it good. I have to offset it by putting this one on top and this one on top. So numerators look like this. X times x minus 5, 3 times 3x minus 2. Okay. Essentially what happens is this. Here's kind of the shortcut. When you have two terms and their denominators are not alike, what happens is this denominator, the one on the left, multiplies to the right. And this denominator, the one on the right, multiplies to the left. And then you multiply them together to make the common denominator. And it works every time. Sometimes you have to reduce it, but this will certainly work every time. Okay, so now I can combine to make one fraction whose denominator is that shared common denominator, 3x minus 2, x minus 5. The numerators need to be combined. Okay, do some distributive property. The first fraction, its numerator is x squared minus 5x. Second one is plus 9x minus 6. I combine like terms, so we get x squared plus 4x minus 6 over that common denominator. That's done. Okay, a couple of things to consider just as we finish this problem out, or as it is finished, but why I know it's finished. You want to check for reducing. Okay, in other words, can that factor? Okay. Because if this can factor, then maybe it can reduce out one of these two down here. Okay, because of that reason, I typically don't multiply the denominators. Just leave the denominators in a factored form like that. Because I want to know if something reduces out of here. In this case, nothing reduces, so that's finished. Okay, another example of adding or subtracting fractions. So it's adding using an LCD, standing for least common denominator. We kind of did that in the last problem. I just didn't talk about it like that. I just kind of did a shortcut, I guess. In order to add or subtract fractions, the denominators are unlike, like we see here. What I'm going to check for first, and I checked for it in the other problem, I just didn't do it out loud. I'm going to check and see if the denominators factor. Okay, this denominator factors with an x coming out, leaving x minus 2. This one doesn't factor, of course. This one factors as a difference of squares, x minus 2, x plus 2. Okay, so now what I need are common denominators between these fractions. Okay, so there are three fractions. They have to have the same denominator underneath all of them. So what they have to have is all the denominators have to have one of everything that we see. All the denominators are going to have an x. All of them are going to have an x minus 2. And all of them are going to have an x plus 2. Okay. If I see it like this, all the fractions have common denominator. Okay. Well, so what did I change about this first fraction? I changed its denominator by putting the x plus 2 there. Well, I have to offset that by putting the x plus 2 on top. This next fraction started with just an x. I have to offset what I put on bottom by putting it on top. This last fraction had x minus 2, x plus 2, but it didn't have the x that I put there. So I had to put the x on top. I have to offset what I do. What I put on bottom must also go on top of the fractions. Okay, well now we can work to put this together into one fraction. First fraction is distributed to 2x plus 4. Second fraction, I'm just going to FOIL these together, and since I'm timesing by 1, it's just the FOIL of that, which is going to be x squared minus 4. Over here I have, whoops, mistake time. This was a minus. I put a plus right here. It should be a minus. So this is going to say minus 3x. Okay. Combine the like terms on top of this fraction gives me x squared. The x's, it looks like I'm going to have minus x. And then the plus 4 minus 4 actually goes away. So it's just x squared minus x. That would look better in the middle of that fraction. I have x, x minus 2, x plus 2 on bottom. The numerator can go farther, so we're not quite done. I can take an x out of the top. And now look, the x that I took out of the top can reduce out with the x from the bottom of the fraction. So the answer now is what's left behind, as they're all different factors. X minus 1 over x minus 2, x plus 2. Finally, I want to look at a compound fraction, or sometimes called a complex fraction. Simply, it's fractions divided by fractions, or fractions within a fraction. It's really just a division problem, so there's not going to be much to it, in that we have seen problems like this, just written differently. The first thing to do, however, is to simplify the top and bottom of this fraction respectively. So the numerator, let's just do it here. I have 3 over 1 minus 7 over x plus 2. I need to make these into one fraction. And if you recall my shortcut from a couple of problems ago, I'm going to take this denominator, multiply over here. I'm going to take this denominator, multiply over here. I'm going to multiply them together to make the common denominator. Okay, so that would look like this. 3 times x plus 2 minus 7 times 1 over, it'll just be x plus 2. Combining these, I've got 3x minus 1 over x plus 2. Minus 1 because I had 6 minus 7. Just went ahead and worked that out. Okay. I'm going to do the same thing in the denominator. Let's change colors for this. I've got 1, which is the same as 1 over 1 minus 1 over x minus 3. Okay, so the way we do this again, we kind of think of this shortcut. The x minus 3 goes here, the 1 goes here. We multiply them together to make the common denominator. So we then have 1 times x minus 3 minus 1 times 1 over x minus 3. So this makes x minus 4 over x minus 3. Okay, so what do I have now? I have, notice there was a division bar right here. So this is still divided, still divided, still divided. I've got this fraction divided by this one. So we have 3x minus 1 over x plus 2 divided by x minus 4 over x minus 3. So we change the appearance of this. It looks like something we've seen before. This is the same as 3x minus 1 over x plus 2 times x minus 4. Whoops, that should be a 3 and that should be a 4 because we are flipping this. Well, what we'd want to do now is check, can we factor anything? The answer is no. Can we reduce anything out? Is anything the same? The answer is no. So really that's the answer. The answer is 3x minus 1 times x minus 3 over x plus 2 times x minus 4. Okay, one final example of simplifying a compound fraction. We'll go a little bit faster this time, as we've kind of seen the process already. First I combine the fractions on top. So this one goes here, this one goes here. This becomes b squared minus a squared over a squared b squared. And then on the denominator, this one goes here, this one goes here, so this becomes b minus a over ab. Now, since this is a division problem, we'll rewrite it as a product. B squared minus a squared over a squared b squared times, and we're going to reciprocate this, ab over b minus a. Okay, next we need to check, can I factor anything? Well, the numerator of the first fraction is b plus a, b minus a. I can't factor anything else. But just that little bit of factoring allows me to reduce this fraction. B minus a cancels out b minus a. Of course, one of these a's takes out one of these. This b takes out one of these. And we are left with a reduced fraction that is b plus a over ab.